Hello, dear viewers. I'm pleased that we are able to show you exciting topics and news from the WAGO world in this new format of the webcast. In this webcast ground resistance signaling module, you will now receive interesting information on the topic of preventive maintenance. Feel free to ask me questions at any time using the live chat function. If you're watching the video at a time when the chat function is not available, please feel free to contact our support team on the WAGO website. Before I start the actual topic, I would like to introduce myself briefly. My name is Frank Selke. I'm an electrical engineer and I'm with WAGO for more than 25 years in international sales. I have visited customers in almost 50 countries from the fields of mechanical engineering, automotive, process industry and others, and have made them aware that our products can do for them special things. And now let's start with the topic for you. Major topic in many companies is cost savings. One possibility to realize this is the so-called preventive maintenance. In the automotive industry, figures of around 50,000 euro per minute are circulating, depending on the vehicle type, sometimes more, sometimes less. Such sums for production losses are also found in other industries, for example in the pharmaceutical industry or in refineries. One possible reason for a production standstill is a ground fault. And this can be detected using various methods to minimize economic consequences. Any dangerous consequences of ground faults must be prevented anyway on the basis of the standard IEC 60204. The standard states, measures shall be provided to reduce the probability that insulation faults or ground short circuits on any control circuit can cause malfunction, such as unintentional starting, potentially hazardous motions, or prevent stopping of the machine. Problems that can be caused by ground faults are starting of unintentional dangerous motions. Think of a robot. If a robot is near a worker and starts unintentionally moving his arms, that could be very dangerous for the person. The robot is always stronger than any human being. Also, that a machine can maybe not be stopped, although one wants to do so, is causing dangerous situations coming from ground faults. And also analog signals can be falsified by ground faults. So think, for example, of a boiler that has already maximum temperature, and now the temperature reading is falsified by a ground fault. So the PLC thinks it is less hot than in reality and starts heating the boiler. That may lead to an explosion if other safety measures fail. Early detection of ground faults helps to avoid immediate machine standstill, which means a loss of production. So it helps to save downtime costs. And preventive maintenance becomes possible, since early detection maximizes the repair time window. What is a repair time window? We have prepared a graph for that. So here you can see the insulation resistance versus the time. And in the beginning with a new machine, the insulation resistance is very high, optimal. But over time, when there is sunshine exposure or when mechanical stress is coming to the wires, that insulation resistance level may decrease and finally lead to a short circuit where then the fuse tripping threshold is achieved. So the fuse opens the circuit when the isolation resistance is very low. That means sudden standstill of the machine. If one applies measures to detect the threshold of isolation resistance earlier, then we gain time, and that time can be used for preventive maintenance measures. Various solutions can be used to meet the standard. So the standard itself makes a proposal, method A, to ground the 0 volt. And in the most simple way, this can be achieved by a simple wire. So you make a connection between the 0 volt terminal of the power supply and the PE terminal block. Together with the fuse, that means that a low ohmic ground fault will immediately trip the fuse. So you have immediate shutdown of the machine, and there is no warning in advance. That is not nice, but at least it is safe. People that are not willing to have the expenses of the downtime, they spend a little more money for a ground conductor disconnect terminal block. Here we can see that the disconnect knife does the same job like the simple wire. It connects the 0 volt to the PE. And in addition to that, it offers LEDs that can be evaluated in the maintenance routine. When opening the disconnect knife, you can watch the LED reaction and get information about upcoming ground faults. The sensitivity of this solution is round about 500 ohm at 24 volts. And here comes now our answer, our innovative product, the ground resistance signaling module. It is exactly in the same way wired like the ground conductor disconnect terminal block, but offers 2 additional wires with a potential-free contact that can be evaluated by a PLC. Internally, there is a power MOSFET that does the job like the disconnect knife. It connects all the time 0 volt to PE, and in 10 seconds there is only for a split second an opening of this connection to make a fully automatic measurement of the insulation resistance. The result of this measurement is being displayed by LEDs and by the potential-free contact. So this product reduces the maintenance interval down to maximum 10 seconds. And there is no more remaining risk due to possible operating errors coming from the ground conductor disconnect terminal block. When one leaves the disconnect knife open, the fuse cannot act to protect in case of ground fault. Let me introduce the features of the product. First, to mention the clear signaling. 4 LEDs and a potential-free contact are giving indication in case of a ground fault. When the value falls below the non-adjustable limit value of 4 kilo ohms, the green LED stops shining and the red LED starts shining, indicating this alarm. The other 2 yellow LEDs will indicate whether the problem was on the 24 volt side or on the 0 volt side. And the potential-free contact can be used to be daisy-chained together with other contacts coming from DC-OK of power supplies, for example, to reduce the need of inputs in the PLC. And we have a selection of the operation mode. The slide switch here enables switching between the grounded operation and the ungrounded operation. In the grounded operation, the power semiconductor always makes the short connection between 0 volt and PE. If it is the ungrounded setting of the switch, then this semiconductor is not active and you have never a connection between 0 volt and PE. And here we have our comfortable connection with push-in cage clamp and push buttons. Any kind of conductor can be connected comfortably. And inside there happens an automated evaluation of the insulation measurement. In the grounded operation mode, every 10 seconds the circuit is measuring the insulation resistance between 24 volt and PE or 0 volt and PE. In the ungrounded setup, this happens every second. And now let's see how this product works in a real application. Here we have our demo prepared for exhibitions. That shows the 3 different solutions fulfilling the standard IEC 60204. On the left side, the simple wire. In the center, our ground conductor disconnect terminal block. And on the right-hand side, our new ground resistance signaling module. There are LEDs indicating the status of the fuse, and we can reset the fuse by this push button. In case that the new module has alarmed about a ground fault, this is being indicated by this red lamp coming from the PLC. Let's start with the explanation of the ground conductor disconnect terminal block. Next to this, we have terminal blocks where we can place certain resistors to simulate the ground fault. Typically, when there is no ground fault and the insulation is fine, every 3 months an operator opens the cabinet and handles the disconnect knife. So in this test, when there is no ground fault, together with the always shining green LED, now the red LED starts to shine. That indicates and reminds the operator, please close the disconnect knife again, otherwise the fuse cannot act because we have interrupted the 0 volt to PE connection. So after the finding, the operator needs to close the switch again. Now I'm preparing a ground fault that can be seen by the ground conductor disconnect terminal block. 470 ohms. After applying this ground fault, there is no visible reaction on the product immediately. But when the operator comes back for a test and opens the disconnect knife, now we see that the green LED stops shining and the red LED again starts shining to remind, please close the switch. So this is a clear indication that now the isolation is not okay. So one can start finding where is the problem, and as soon as one finds the problem and solves it, the green LED comes back to life and says, now the isolation is okay again. Next thing I would like to show is the short circuit. Here we have a 0 ohm component plug with a wire inside. As soon as I place this component plug between the red and the green-yellow terminal block, we make a short circuit and the fuse opens. That is the intention of the product in case of a low ohmic ground fault to interrupt the operation of the machine. I also would like to show what happens if one does not close the knife disconnect, because then this action of the fuse is being prevented. Let me open the knife and reset the fuse. If I now do the same thing again, make the same short circuit between 24 volt and PE, only the green LED turns off, but the fuse has not acted, has not tripped. Only when the knife is closed, at this moment the fuse is opening. So never forget to close the disconnect knife. Now let's have a look how the new ground resistance signaling module is working. I start with a resistance of 16 kilo ohm that is above the threshold to be detected. I put it between the red and the green-yellow terminal, and we have to wait for 10 seconds minimum because that is the measurement interval. So I can talk a little bit and we see that there is no change from the green status LED indicating that the status is okay. Now for sure we have reached 10 seconds and still no reaction. Let me change this to a resistance value that can be identified by the module. It is 3.3 kilo ohm. Put in the same position. And with this lower isolation resistance, we will find after latest 10 seconds that the status of the green LED OK changes to the red LED of isolation alarm, and the upper yellow LED is indicating that the problem took place on the 24 volt side. In addition, our red lamp is activated by the PLC after reading the potential free contact. If we do the same thing now on the 0 volt side, in the meantime it turned back to green. When I was pulling it off, it was okay for this time, but I have reinstalled the isolation problem on the 0 volt side, and now after 10 seconds we find the same alarm message with the red LED, and now the lower yellow LED is indicating the problem is on the 0 volt side. And again, as soon as I find and solve the problem, the module indicates everything is okay again. And this is now. And now I would like to demonstrate the reaction of the module if you have a really low ohmic ground fault, like a short circuit. And applying the short circuit, you see the same reaction like with the ground conductor disconnect terminal block, immediately the fuse is acting and cutting everything off from power, so that is not nice but safe. But you always get a maximized repair time window because of earlier detection of ground faults with the new module. So let's summarize the benefits of the ground resistance signaling module. First, to mention the time. We are reducing the service time coming from 3 months for the ground conductor disconnect terminal block down to 10 seconds with our new module. And this maximizes the repair time window. And we also need less time for the maintenance people that do not any longer have to operate the ground conductor disconnect terminal in their routine. Secondly, we have increased safety because we reduce the risk of errors due to the elimination of manual operation. This is all happening fully automatically inside the product. And digitization. Digitization of the status report, that means we have now a signal directly for the PLC that can be evaluated without human influence. And we have cost savings. There's lower risk of a production standstill coming from the module. And we are compliant with the regulations. This product helps to fulfill the standard IEC 60204. I hope I could provide you with new and exciting information about the topic of ground resistance signaling module. Please feel free to use the Meet the Speaker function afterwards, where you can go into an exchange on the subject of preventive maintenance. If you have any questions, please contact our known contacts or use the contact to our support team on the WAGO website. There you find additional information about the new ground resistance signaling module. Thank you very much for your attention and stay safe and excited.